Now we are starting our module Introduction to Quantum Mechanics. By this chapter, my intention is to make you to differentiate classical mechanics and quantum mechanics and the failures of quantum mechanics that urged the need of quantum mechanics. Then we have a simple differentiation between particles and waves. Particles are material objects like ball, car, a person that can locate at a space point at a given time, while waves are those having crests and troughs. Ripples in water, ocean waves, sound waves, etc. come under this category. These particles, which can occupy a definite space and can be defined by its position at a particular time, come under classical mechanics, while the wave nature could be defined by quantum mechanics. For further clarification, I will explain some features of classical mechanics. The main point is that for classical mechanics, it provides a definite path for a particle. That is, if we are throwing a stone or driving a car, we could identify its position at any time and also can have its speed at any point, as the velocity is the change in position with respect to time. And we can also get its momentum as it is P, momentum equal to mass into velocity. The main essence of classical mechanics is given in Newton's law, which is force equal to mass into acceleration. That is, for a given force, if the initial position and the velocity of the particle is known, all physical quantities such as position, momentum, angular momentum, energy, etc. at all subsequent times can be calculated. This happens only for particles that can occupy a definite space. I am revising some relevant equations in classical mechanics that all you know, which is total energy of a particle can be obtained as the sum of kinetic energy and the potential energy, where the kinetic energy depends on velocity and the potential energy depends on position. We can have another equation of total energy as the kinetic energy is half mv square plus the potential energy V. As P is equal to mv, we can also write it as E is equal to P square by 2m plus V. That is, we can, if we know the position, we can have the kinetic energy, potential energy and total energy. All can be defined at a particular time. I am repeating, these all can happen when we are treating a thing as particle and it should occupy a definite space. I conclude this lecture with these basic equations and ideas that you are already familiar with, and in the next session we will deal with the failures of classical mechanics. Thank you.